Your scattergraph from data classroom. We're going to do a number of things with the data. Now you notice these were different groups, right, for different concentration levels. It would be nice to plot the mean and maybe get the error bars as well for this kind of group of data here. So we can do that quite easily with descriptive stats. Automatically, look, it's chosen to plot the mean and it's given the standard deviation. You can see on the bottom of the graph here. It looks a little bit cluttered, so we can go into the appearance here and the point size. So the actual individual data points we can make as small as we want, right? We can play with that. And then if you go down here for the actual mean error bars, the mean dot size, you can make smaller as well. So again, you can play with the look and the feel of the graph there. We can close that. You can actually get the values as well. So here we can see that the mean values, remind me later, the mean values for each concentration level are given here with the standard deviation, so that's quite nice. Sometimes you might want to know, are there any outliers within any particular concentration level group? As you can see, this is the standard deviation for this data set, and you've got these couple of extreme points. Are they okay, or are they outliers? Well, what we can do, oh, and don't forget, each time you have a new looking graph, you can click on this little guy and take a screenshot of it. There you go, and you can copy to clipboard and you paste it into your document, and you can then tweak it as you want. Over here, instead of mean based, I'm actually going to choose a median based now. Okay, so what we've got here again, we've got a box plot, and within the box and whiskers over here, show dots, we can see if there are any outliers. So here we are going to choose the outside 1.5 IQR, and it tells you what the definition is for an outlier. So if it's plus or minus 1.5 times the IQR above the quartiles, then it will be considered an outlier. And there is nice details about outliers in this guide, which is kind of cool. Let's go back here and let's confirm, and let us see. It looks like there are, yep, looks like there's no outliers within each of these concentration levels, right? Because beyond the whisker here, there are no points highlighted outside. So it looks like there's no outliers on the graph. No outliers in each of those data sets. If there had been, would have seen little dots above the edge of the whisker. So now let's go and click on the show outliers. We're going to show the dots again, and that will just toggle off that little function about finding outliers. Now I'm going to go back to the nice look of mean based, right? So there's the mean data point for each of the concentration levels. Those are the error bars, the standard deviations. That looks pretty good. And now let's go and report the regression line. So we want to see the regression line. So the regression line gives you an equation, right? So the dependent variable is equal to 0.0394 times concentration level plus 1.904. And it tells us that there's an R squared value here, which is 0.9. If we square root that, we would get the correlation coefficient. But we want to know, really, it looks like there's strong positive correlation within this experiment that we did, but we want to know if this is a significant relationship, right? If we kept taking more and more trials and just did, hundreds and hundreds of thousands, are we still going to see this kind of general relationship? And that's where we do the hypothesis test. And we're going to click on the magic button here, click, and it automatically tells us we're looking for linear regression, right? Is there enough evidence in our sample to kind of generalize to say, yes, for higher concentration levels, there will be a higher dependent variable. So we go calculate. It tells us a little bit about when we should do it. So this might be justifying why you chose that test. You can have a little read here. And then when we calculate it, it's going to give us this magic p-value. So a p-value is a likelihood, right? It's a likelihood. So the p-value technically is, what's the chance that I got those results just by pure chance, just by luck, right? So it's a less than 1% chance that those results happen just by pure chance or luck. So this p-value seems there's extremely strong confidence there's a significant relationship, and the relationship in this case is there's a linear correlation, all right? So you can actually take a copy of that or just have a screenshot of the p-value, and that's done. And so in conclusion, we can say that for this experiment, we seem to have strong evidence to say that for higher concentration levels, there is clearly a higher dependent variable, whatever that dependent variable might be. And yeah, there you go. Hope that helps.